Hello everybody, today we're going to be translating tangent functions. Now before we go deeper into this topic, I first would like to just iterate that this method used in this video can be used with any other basic trig function. It's not in any way unique to tangent functions. It's just the reason why I put this off into a separate video was just so that you could study more efficiently. If you were having trouble with tangent functions, you could choose this video instead of trying to scroll through videos trying to find different tangent problems mixed in with sine and cosine and other trig problems. So this is just about translating tangent functions, and so yeah, I hope you enjoy. So basically we're using this generic formula for trigonometric functions, and so A is this amplitude and gives the vertical stretching. D gives the vertical shifting up and down. The period of the function is just the period of the basic trig function. So for tangent functions, the period is going to be pi for the basic tangent function, and then over the absolute value of b. And then to calculate the horizontal shift, you just set this equal to 0, and you solve for x, and that x will be your horizontal shift, and if it's negative, it shifts it to the left. If it's positive, it shifts it to the right. So without further ado, let's go see some examples and see how these concepts apply to tangent functions. So for our first example, we're going to be graphing y equals tangent of x and y equals tangent of x minus 2. And I have a table here that I computed ahead of time, and basically when theta is equal to, or x in this case, but when the angle is equal to negative pi over 2, there's no y value, it does not exist. When x is equal to negative pi over 4, it's equal to negative 1. When it's 0, it equals 0. Pi over 4 equals it equals 1, and at pi over 2 it does not exist. There's nothing that exists there. So you see these do not exist there because of the fact that since tangent's related to y over x, and x goes to 0 at pi over 2 and negative pi over 2, this creates a discontinuity, or does not exist, because you cannot divide anything by 0. Here y goes to 0 when but the thing is since y is in the numerator, it doesn't impact the entire it does not impact it like that, because it's 0 over 1, which is legal, so it equals 0. So that's just kind of a quick side note. And so now we can kind of graph this. So here are the so here is negative pi over 4, negative 1. This is pi over 4, positive 1. And so then we just kind of then we draw some asymptotes in here like that. Like that. And so now we just kind of draw it in. So it goes through the origin, and then it just keeps repeating over and over. So I could draw this again like that, and so on. Now to get tangent of x minus 2, all you do is you just simply subtract 2 from each of these values. That does not exist, still does not exist, but this becomes negative 3, this becomes negative 2, then this becomes negative 1 right here. So then what happens is now what we get is a function that looks like this. Like that. And so that would be how you would graph tangent of x minus 2. You just are subtracting 2, you're shifting it downward 2 from the original tangent of x function. Alright, so our next two examples are y equals 2 tangent of x and y equals negative 2 tangent of x. And so basically, they just are pretty much multiplied by a scalar. Like if you look at these values here for tangent of x, you just simply multiply all of these by 2. So to produce the graph of 2 tangent of x, if I were to say, okay, here we have pi over 2, here we have negative pi over 2, and then we add negative 2 here, positive 2 here. So then I create my vertical asymptotes, like so. The graph of tangent would just increase at a faster rate. So now now we have 2 tangent of theta. And right here we have, just as a sample point, just to show you how the value of y is twice as high when it's at pi over 4. So there is 2 tangent of x. Now to produce negative 2 tangent of x, all you do is you just simply reflect this over the y-axis. So you create this second function that looks like this. And so that's how you just use the so that's how, like, if you have like a coefficient, some integer, some real number in front of a trig function, that's how it affects it. It just multiplies it by that number. So if it's positive, it just makes it stretches it, vertically stretches it twice as much. If it's negative, it just flips it over the x-axis and it stretches by the same factor. So these are our 2 functions, yeah. So let's move on to the next example. All right, so for our next example, we're going to be graphing y equals the tangent of 2 of x and y equals the tangent of 2x plus pi. So in order to do that, what we need to do is we need to first find the period, which is just the period of the tangent, which is pi over the absolute value of b, which equals pi over 2. So since the period is pi over 2, it's half the other period of the original tangent function. It has vertical asymptotes at pi over 4 and negative pi over 4. I'm just going to label the y-axis while I'm at it. And so now we know that we have 2 vertical asymptotes here. And if you're skeptical of that, what you can do is you can plug y equals, so tangent of 2 times pi over 4. And what you'll see is you'll get tangent of pi over 2, which equals nothing. It doesn't exist. Because now with that 2 in there, you get pi over 2 when you have pi over 4. You put the value of pi over 4. So now what you got to do is just graph it like that. And there you go. You have y equals a tangent of 2x. To get y equals tangent of 2x plus pi, what you have to do now is you need to input. You need to input the equation 2x plus pi equals 0 to find how far it's shifted over horizontally. So you just set it equal to 0, and then you solve for x, so subtract pi from both sides. Then you get 2x equals negative pi, divide both sides by 2, and so you get x equals negative pi over 2. So you shift it over negative pi over 2, and it has it still has a period of 2 pi because they share the same, not 2 pi, pi over 2, because they share the same b value of 2. So the other vertical asymptote for this function will occur at 3 pi over 4. So then you just draw in the vertical asymptote, and voila, you have your function y equals tangent of 2x plus pi. So now we're going to take all the skills we've learned and we're going to apply it in one big problem. So for our final problem in this video, we're going to be solving the problem y equals 5 tangent 3x plus pi minus 1. So right from the get-go, I can already find a few important details about this function. One of which we have an amplitude of 5. And it's also shifted downward by a factor of negative 1. So now, next thing we can kind of find is we can find the period. Well, we know the period of tangent of x is pi, and we divide it by 3. Well, the absolute value of 3, which equals, and you get a period of pi over 3, highly important. And then what you want to do is we just need to find what the horizontal shift will be. So just take 3x plus pi, set it equal to 0, subtract pi, and then you get x equals negative pi over 3. So it's shifted over negative pi over 3. So you get negative pi over 3. And now since the period is pi over 3, it goes from pi over 6 to, negative pi over 6 to negative pi over 2. And so we just draw on your vertical asymptotes like that. And now we got to think about it being shifted down by negative 1. So then if we have negative 1 here, we got 1, let's just label these axes, and same down here. And so now think of negative 1, it's going to have, it's going to start here. This is like equivalent to the 0, 0 of the normal tangent function. And so now it has a amplitude of 5. So halfway between here, it's going to move up 5. So 1, 2, 3, 4, 5. So here's this half of it. And same thing down here. So it's going to move up. It's going to go 5 in this direction. So 1, 2, 3, 4, 5, and it's scaled up by 5. So here we go. And voila! Here's your function, 5 tangent of 3x plus pi minus 1. And so thank you for watching this video. I hope you found this helpful, and feel free to leave questions or comments below.